Okay, welcome everybody to our lecture. This is an exceptional time for us. It's really with great pleasure to introduce Professor Tim Flannery here, legendary biologist for everybody working in New Guinea as well as the Pacific. He is an expert in mammals, and he was really one of the first modern explorers of fantastic mammalian fauna of New Guinea, then expanded his interest to the whole Pacific. Some of his monographs have several kilograms, and that is also advertisement for tomorrow's lecture, which will be on mammals of New Guinea. So everybody is invited here again for tomorrow. But that's not the end of the professional CV of Professor Flannery, because then he became widely known, I would say globally, on the global scale, known for his climate change work, both on the margins of science and politics, trying to get support for climate change, explaining the climate change to, I would guess, millions of people, and that will be the topic of the current lecture. It also was the basis for him to be awarded the Australian of the Year award some years ago, 2007. And so I would like to conclude that to me, Professor Flannery, in addition to being somebody whom I have known from the books and from the stories of Papua New Guineans much well before we actually first met yesterday in person. He's also ideal example of somebody who is a scientist, professional biologist, and at the same time excellent science popularizer, because he is a biologist with very broad scope, basically arriving to a continent and then producing extremely interesting book on the ecology of the whole continent, which I think he could be excused for doing that for Australia, his native continent, and that's the book Future Eaters. But somewhat annoyingly to other people working on science popularizations, then he arrived to Northern America and immediately produced an excellent book on the ecology of that continent, and then he did the same for Europe. So I really recommend. Unfortunately, we don't have the third day for the lectures here, so we have to skip, or maybe also fourth and fifth, so that we get all these continents covered. We can't do that, but I will refer you to his books. Anyway, let's go back to the very complicated and at the same time very simple topic of climate change. And floor is yours, Professor Flannery.
Thank you. Thank you so much. And could I just begin by thanking Professor Novotný for making this visit possible? You've been a very generous and wonderful host. It's been fantastic. And I'm delighted to be here. It's my first visit to the Czech Republic. I don't even have one word of Czech. I'm sorry. It's going to have to be English all the way through. But I am learning about the university and the things that are done here. And it's really quite inspiring, actually, particularly the work you are doing, mentoring and assisting students from the South Pacific is really important globally. But what I wanted to do this afternoon is really talk to you about climate change. I want to give you an overview of the basic science and then have a look at just the last few months and what we're learning about the way our climate is changing and the implications for our future. So I'm from Melbourne University Sustainable Society Institute and Faculty of Science. But I spend most of my time at the Australian Museum in Sydney, which is where I work. I was a curator there for many years, and I now work there as an honorary. So the first point I really want to make is that climate science is a very old science. You'll hear climate skeptics say that a lot of it has been invented in recent years. That is just not true. So the very earliest intimations of how the system works were developed by this man here, John Tyndall, who was director of the the Royal Society institution in London. And in 1859, he invented this steampunk-looking machine here, which demonstrated the warming potential of carbon dioxide. So that demonstration was really the beginning of our understanding of how greenhouse gases can trap heat in the atmosphere and change our climate. And that was done way back in 1859. Since then, the science has developed quite rapidly. We use computer models these days to understand how the system works and what the impact on the system is of greenhouse gases. And these few graphs here that I'll explain in a moment are very representative of the recent science. But I just want to say to you that the data that's presented here has really remained unchanged for most of the 20th century. The first person to do the calculations that revealed this data was Svante Arrhenius, a Swedish Nobel laureate, who did it all longhand. He had a very miserable marriage, apparently, and he spent long hours in his laboratory doing sums of the impact of greenhouse gases on the atmosphere. After 18 months of work, he understood that by doubling the concentration of CO2 in the atmosphere, we would raise the global temperature by 2 to 3 degrees Celsius, which is still about right, still where even with all of the sophisticated computer capacity we have today, those figures remain broadly the same. So what do these graphics show us? So what we see here is you can see the names of the regions of the world here. This is North America, Europe, Asia, and so on, through to global, which is everything, land and waters. And this is what's called backcasting. So what the computer people have done here is mapped out the actual temperature changes and then taken two sets of data to see which one fits the actual data for the 20th century the best. So what you see here is this is the purple envelope here. That data set includes all information about the way the climate system works and all of the feedbacks, so volcanoes and sunspots and everything else, but does not include the human influence. So it doesn't include the greenhouse gases we create through combustion of fossil fuels. The red envelope, however, includes both the natural factors and the human influence. And you can see in every case, the real world data, the actual data on temperature, only maps against the total data set that includes the human influence. So this is how we know that we are influencing Earth's climate. Yeah, we can do the experiment through this backcasting, exclude the human influence, and the real world record is inconsistent just with the natural causes of climate variation. It's true for every region, it's true for the oceans and true for the global society. And you can see there's a few instances here where neither parts of the curve, neither envelope represents reality. That just tells us we still have things to learn about the way the climate system operates. So the most difficult problem we have when we're thinking about climate change is simply scale. It is impossible for us humans to comprehend the volumes of greenhouse gases that are involved, the transfer that is involved. This artist, Steve Halley, works with computer files. He's a computer artist, and he decided to try to express in a piece of artwork the amount of oil that is extracted from the Earth's crust in 1 second. And you can see that here. See, these are barrels of oil. They just go on seemingly forever. So there's a large volume of oil being extracted every second of every minute, of every hour, of every day around the planet. So just on top of that, you have to put the piles of coal that we dig up, which far exceed in volume the oil. And we then have to include on top of that all of the gas that we're extracting from Earth's crust and lay that on top. And then when we combust all of this, we create 2 to 3 times in general the volume of CO2 relative to the volume of hydrocarbon that we're burning. So the scale of the amount of material we are putting into the atmosphere, CO2, is very, very large. It's unimaginably large. So you may say, well, that doesn't matter because look outside, look at the atmosphere. It goes on forever. Yeah, it looks like it goes on forever, doesn't it? It looks very big, the atmosphere. But do any of you know how large the atmosphere is relative to the oceans? Who thinks the atmosphere is larger than the oceans? Quite a few. Yeah, it looks larger than the oceans, but consider that liquids are 770 times denser than gas. It's for the ocean and the atmosphere. And knowing that, you understand that the atmosphere is 1/500th the size of the oceans. So the oceans are 500 times larger than the atmosphere. So these very large volumes of CO2 that we are putting into the atmosphere actually register in terms of the composition of gases in the atmosphere overall. And this is how we can see that CO2 concentrations have risen from 280 parts per million, which doesn't seem like very much, but it is important, as we'll soon see, before the Industrial Revolution, through to 427 parts per million today. If we look at the carbon budget and the carbon cycle, we get greater clarity about the interchange of carbon from the Earth's crust, the oceans, and the atmosphere, because carbon is continuously cycling through the rocks of our planet on a longer time scale, into the oceans and into the atmosphere, constantly being interchanged. So this is a little bit old, these figures, going back to 2015, but the basic principle remains the same. So what we see here is that we are pumping out about between 9 and 10 gigatons of carbon from the Earth's crust every year. So that's taking carbon out of the rocks, where it's remained buried for hundreds of millions of years. So we're taking that number out, 9 to 10 gigatons, billion tons. But some of the carbon is going back into being taken out of the atmosphere and going into the biosphere or the rocks. We can see here that about 3 gigatons goes into growing forests. So plants use the power of the sun to capture CO2 from the atmosphere and build tissues, build bark, roots, leaves, everything else. And we can see here that 2.6 gigatons on average goes into the oceans. Now this is very important because the amount that goes into the oceans and stays there and the amount that remains in the atmosphere is determined by the partial pressure of CO2 at the ocean surface. So if we all of a sudden start taking CO2 out of the atmosphere, you can appreciate what might happen. CO2 outgasses from the oceans in compensation. So this means that when we turn to technologies we'll discuss in a moment for taking CO2 out of the atmosphere, we have to understand that the volumes we talk about are very, very large. So basically, to cause a decrease in atmospheric CO2 concentration of 1 part per million, remember we're at 427 parts per million, so to take 1 part per million out of the atmosphere requires a drawdown and sequestration of 18 gigatons of CO2. The reason that is so large is because the volumes of CO2 in the ocean that will outgas as we release and lower the pressure of CO2 in the atmosphere. So the bottom line with this graphic is really here. We put in about 9.3 and about half of that, 4.5, stays in the atmosphere. The rest goes into the oceans or forests. So half of the CO2 we produce remains in the atmosphere on average, driving up that concentration. Oh my goodness, I'm sorry about that. That says over 1/3 of all of the greenhouse gases ever emitted by our species were emitted since 2007. Can you imagine that? 1/3 since 2007. That is a huge amount. It tells you how rapidly we are increasing the emissions of CO2 and how large they have become. We'll be at 1.5 degrees above the industrial average within a decade. We may already be there, and we'll return to that in a moment. And so those greenhouse gases are coming from a number of sources. And this rather complex diagram gives you a sense of where they come from. Again, it's an old figure, 2010. We're probably at closer to 60 gigatons now. And see this little thing here, CO2 equivalent? It's important to understand that there are more than one kind of greenhouse gas. There are 5 kinds that we measure regularly. There's methane, nitrous oxide, the HFCs and so forth. But we convert the warming potential of those greenhouse gases into CO2 equivalent units. So this is the figure for CO2 equivalent units. That includes all the methane, which is about 20% of the warming potential, the nitrous oxide and so forth. So, and here's where they come from. Transport, industry, buildings, AFOLU, very confusing thing. That is agriculture, forestry and other land use. So this carbon here is really different because it's already in the biosphere. This carbon, by and large, is coming from the geosphere, from the Earth's crust, where it's been sequestered for hundreds of millions of years. Different system. So there is a lot of inertia in the climate system. The greenhouse gases that our grandmothers emitted when they were cooking your grandfather's and family's dinner on an old wooden stove, a lot of that is still in the atmosphere. The CO2 lasts there, has a half-life of about 100 years, but it doesn't even reach its full warming potential for 20 years. So 1 molecule of CO2 I'm breathing out now will not reach its full warming potential until 2044. Yeah, it will continue increasing the amount of heat that it is able to capture. Added to that, we have inertia in the human system. We can only build new energy systems by using the existing polluting ones. So when we build a wind turbine, some of the energy required to build that wind turbine is coming from the burning of coal or gas. Yeah, so that means there is inertia in the system. We can't just instantly change from one to the other. And of course, all the time, climate thresholds are being crossed. And as they are crossed, they can trigger positive feedback loops. I now just want to turn to the island of New Guinea, because we have some fantastic Papua New Guinea students in the audience today, just to start looking at the impacts of everything we've just learned. So these are 2 tree kangaroo species, which are found in high mountains in New Guinea. They're restricted to alpine or subalpine or upper montane habitats. And this one particularly lives on a low mountain range. And it's probably restricted to within 900 meters of the peak of the mountain range that it's on. We know from 20th century experience and looking at museum collections of birds particularly, that tree lines rise by about 300 meters for every 1 degree C of temperature increase. So we're already about at 1.5. So that's roughly 500 meters of elevational uplift for all the zones on the mountain. So a species with 900 meters of elevational range, we can anticipate by 3 degrees of warming, will have no habitat left. Yeah, that's kind of clear. Yeah. So, and these are very spectacular mammals and large mammals, but they are really flag holders for many, many thousands of species of insects, plants, smaller mammals, birds, reptiles, and amphibians that exist on the island of New Guinea in these critical habitats, which are being squeezed by the warming of our planet. And this really is the reason that I first got involved with climate change. I love New Guinea, I love its mammals, and I realized in the 1990s, by understanding this, that they really had no future unless we could address climate change and slow the warming. So climate change is not just affecting animals, it's affecting our food security as well. This is just an average basket of fish types that you might pull out of the Atlantic or Mediterranean oceans and seas. And they are really shrinking. So 8 commercial fish species in the North Sea have been studied. They've all shrunk in size over a 40-year period, coincides with 1 to 2 degrees of warming. And that results in a 23%, almost a quarter decrease in yield. And yes, overfishing is part of that story, but also the warming oceans are a part of that story because warm oceans hold less oxygen and less oxygen make it very difficult for large fish to survive. Global food security is also under threat. For decades now, as a result of the Green Revolution and other initiatives, global hunger has been decreasing. But as of this slide, one must have been put together about 2022, global hunger had increased 3 years running due to extreme weather. So that great triumph we had of being able to feed everyone is now under threat as more extreme climate events are felt in the agricultural system. We have made some breakthroughs. The Paris Agreement, where the nations of the world agreed to cap warming at 2 degrees and as close as possible to 1.5. It looks pretty triumphant, but when we look at what we've achieved since then, you'll see that there's an underlying truth that is hard to reconcile with the political statements. And on the positive side, I just want to look at, well, 2024, 23, 24 has brought some massive changes. Biden's legislation, Joe Biden's legislation, the Inflation Reduction Act, unlocks $1.7 trillion of investment. So that's just kind of starting to be unrolled now, and will have an impact as we go along. The Ukraine war, as you know, here in Europe has speeded measures here. There's less gas imports from Russia and less fossil fuel burning. People are getting very serious about deploying clean energy, wind particularly, and solar. And China is really doing incredible things. They're beating their targets, what look to be impossibly ambitious targets for emissions reduction. They're actually beating them now. They've deployed or installed half of all clean energy infrastructure globally over the last 12 months. So it's wind and solar is just going ahead. And of course, electrifying transport. So what's happening in China with electric vehicles makes Elon Musk look kind of irrelevant on the side. They're doing it at such a scale with so many companies. And what's exciting is they're doing it in an integrated way, starting with batteries and going right through to a completed vehicle. So, and costs are being driven out of the manufacturing process as they build their probably 100 millionth vehicle. Scale is everything. So that is the end of that part of the presentation, which is the basic science. And we touched a little bit on what is happening now, but I just want to run through a few facts and figures now on where the global Earth system is at. So if we took Earth's average temperature between August 2023 and July 2024, the average global temperature for that time was 1.64 degrees above the pre-industrial average. So you know how we pledged at Copenhagen to stay below 2, but as close as possible to 1.5? At least for one 12-month period, we have reached that level. Temperatures may drop back, but there's no guarantee of that. But what is clearer is the trend, inexorable trend of rising temperatures will see us reach 1.5 consistently within this decade. The CO2 concentration as of April 2024 was 427 parts per million, so the highest ever recorded. Emissions were also of CO2 and other greenhouse gases were also at an all-time high, although the rate of growth is now slowing and it seems possible that we are at a peak or that 2025 will be a peak year for emissions. And that is largely due to the work done in China. China is responsible for about 40% of emissions, so the work that they do is really important. You know, sometimes people say, well, where is our Churchill of climate change? Our man who will stand against the world and deliver clean energy? I think he's the Xi Jinping in China. Just like Churchill, not everybody liked him. He wasn't very popular. Churchill was voted out in 1946, voted out of office. Xi Jinping has his own problems, but he's deadly serious about the clean energy transition and almost single-handedly is driving the largest part of it. Finally, I just say that 2023, the calendar year 2023, saw the largest ever increase in atmospheric CO2 concentrations of 4.6 parts per million. So you might think back just a few years and you read in the papers increases of 2 degrees, 3 degrees, 2 parts per million, 3 parts per million. Well, we've seen a massive leap in 2023 of 4.6 parts per million. We'll come to why that is in a moment. So you might wonder how politicians can continue speaking about the Paris Agreement and 1.5 degrees if we're already at 1.64. Well, they do it by a sort of accounting sleight of hand. They say, oh no, we must look at the temperature over 20 years on average to even out the interannual variation. But if you take 20 years ago, the emissions were small compared with today. So it gives you more flexibility to hope for an outcome which I think is already sadly lost. So you heard earlier that emissions may be flatlining and maybe will decrease by, China's emissions may decrease by 10% by 2030. That's yet to be seen, but it's possible looking at the trajectory. And all of that is good news, but we have to face the reality that we are still adding in excess of 50 billion tonnes of CO2 to the atmosphere every year. 50 billion. Yeah. So very large numbers still going in, even though we are peaking perhaps in terms of emissions. So even if we reduce emissions dramatically at the absolute extreme end of possibility, it is clear that CO2 concentrations, atmospheric CO2 concentrations, will continue to rise for some decades. Maybe at a lower rate than they're rising now, but they will continue. And all of this means that really, you know, when you look at it from a scientific perspective, the probably most realistic outcome, given current trajectories, is that Earth's average temperature will reach somewhere between 2.5 and 3 degrees above the pre-industrial average by 2100. That seems to be roughly where we're headed. So what we really need to do is strive for the best outcome. We have to work hard to reduce emissions, but we also have to prepare for the worst outcome. We have to prepare for a world in which climate impacts will increase quite significantly into the future. And we have to also face the reality that global, that key tipping points will be breached. So there's already some evidence suggesting that the global ocean circulation system is slowing, is altering, and that the Gulf Stream that brings warmer water towards Europe may start to falter. So that is a possibility. When I first started talking about this science back in about 2000, a bit before that, scientists said the chance was maybe 5% of that happening. Today it's far higher because we can see the slowing going on. The Greenland ice sheet and the West Antarctic ice sheet continue to melt at record rates. So that is adding more water, more sea level rise to the oceans. It's another tipping point. Once they melt to a certain point, they simply won't stop no matter what happens in the atmosphere. We can think of the Greenland ice sheet as a kind of living fossil. You know, it shouldn't exist in the current climate system. The reason it exists is it creates its own inertia. It's a very high ice sheet in the far north, and it creates its own conditions that maintain it. But it wouldn't form naturally if it ever melted away. Destruction of the East Amazon rainforest particularly is been something that's astonished me. You know, I read about the high possibility that those forests may collapse. But to actually see it on the news now of these rivers, which are just empty of water, and incredible forest fires in the Eastern Amazon is really, to me, very, very disturbing. It's doubly disturbing because the Amazon rainforest really depends upon transpiration, evapotranspiration. So winds from the Atlantic bring moisture-laden clouds into the Eastern Amazon. The rain falls on the forest transpires, the trees transpire the moisture, and the winds blow it further into the basin where it recycles and recycles and recycles. So if you break that transmission in the Eastern Amazon, less water is going to reach the rest of the basin. So it's another thing that scientists are watching very carefully. Ocean heating is really, it has increased massively. And as someone who lives in Australia and regularly goes to the Great Barrier Reef, I can tell you it's having big impacts on coral. So, you know, what we're not just seeing now heating in the lagoon of the Great Barrier Reef, we're seeing enormous marine heat waves come in from the Pacific and hit the leading edge of the reef and bleach coral down to 40 meters depth. So these are new events, new things we're seeing as the ocean becomes warmer. All of this is affecting the energetics of the atmosphere. Rainfall is coming in more severe pulses. It's interesting, when you look at the impacts of the greenhouse gases on rainfall events, it affects all of them, but the more moderate rainfall events are less affected than the most extreme rainfall events. They are affected 5 to 8 times more than the more moderate rainfall events, which is why we're seeing these extreme floods, because those very low probability, high amplitude rainfall events are being disproportionately influenced by the warming. Heat waves, they are expanding over the world. In my country of Australia, we're seeing fewer of them over the last half decade, but that's no guarantee they won't be back in future. And of course, bushfires are also being influenced by the warming trend. The other thing that's really been increasing is uncertainty. And I'd like to read you a statement which was issued in the journal Nature on Friday, August 16, 2024, by Gavin Schmidt, who's head of the Goddard NASA Institute. So he is one of the best climate modelers, if not the best in the world, and head of the most capable institute for climate modeling in the world. He said, in general, the 2023 temperature anomaly has come out of the blue. So remember, we're talking about the 2023 4.6 parts per million and the warming. Said, it reveals an unprecedented knowledge gap, perhaps for the first time since about 40 years ago, when satellite data began offering modelers an unparalleled real-time view of Earth's climate system. If the anomaly does not stabilise by August, and it hasn't, a reasonable expectation based on previous El Niño events, then the world will be in uncharted territory. The world will be in uncharted territory. It could imply that a warming planet is already fundamentally altering how the climate system operates, much sooner than scientists had anticipated. It could also mean that statistical inferences based on past events are less reliable than we thought, adding more uncertainty to seasonal predictions of drought and rainfall patterns. So that's the best modeler in the world telling you, my models aren't working anymore. We can't predict the future like we thought we could. So we are at a threshold here where we're seeing very dramatic changes in the climate system that are really undoing our understanding of what the impacts are likely to be. I think one of the most worrying aspects of 2024, which is this year, is that almost no carbon was stored in Earth's natural sinks. So if we go back to that, so this year, 2024, that 3.1 gigatons didn't get sequestered, nor did that 2.6 gigatons. Now, every year we have high variability in what happens, how much carbon is sequestered around the globe. But it is notable that this year we had such a deficit in terms of the carbon sequestered. And of course, that helps explain why we had 4.6 parts per million increase in CO2 in the atmosphere. Is this a one-off event? We don't know. I hope it is. There has been other years when there's been low levels of sequestration. But as Gavin Schmidt said, all bets are off. We can no longer really rely on computer modelling and our previous understanding of how the climate system works to anticipate future changes. So we have a very big job in front of us. We can talk about what we can do about it, perhaps in discussion. There are options. Some people think that drawdown of CO2 or geoengineering are possibilities that should be pursued. And we can have a look at some of those perhaps in our discussion time. But I really just want to leave you with the idea that we are leaving the period of some certainty about climate change. We really don't know what is going to happen. Personally, my own best guide is paleontology. Maybe that's because I study paleontology, and I look back at times when the Earth had equivalently high levels of CO2, and you see a very different world. Not necessarily a bad world, it's just a very different world. So without the models, I think the fossils can offer us some insights. Of course, the thing we don't know is how long it takes to get into that different world. What does the transition look like? Is it 1 year? Is it 1,000 years? Is it 10,000 years? We don't know. But I'll leave it there and perhaps invite Professor Novotný over for discussion. Yeah, I think we're having now. Yeah.
Okay, so the main focus of this meeting is discussion. So this was introduction, and Professor Flannery has both theoretical and practical experience. So you can ask all range of questions, and let's see how it goes. Because this is recorded, then we will have a microphone circulating here. So try to ask your questions to the microphone.
Yes. Okay. So one possibility is that the widespread wildfires in particularly tundra forest biomes has released a lot of carbon. The other is that the ocean surface has been extremely hot, which has led to an outgassing of CO2 because warm liquids hold less gas than cold liquids. So they're two of the big factors involved, but really we're yet to see the detailed science on that.
A significant reduction of emissions can be done at an individual level, or it should be like an industry level?
Yes, that's a good question. It's there is one line of thought that industry is very happy to say it's your responsibility to do something because it lets them off the hook, you know. That is, I suppose there's some truth in that. But the other thing that's important is that by reducing our own emissions and addressing our lifestyles, we become champions for the cause. We become living, visible proof that this can be done. So I think it needs to be both. You know, it needs to be industry, individuals and government working together if we really want to optimise the reductions. And we see how China has done it. It's been so effective, incredible, that they've been able to both decarbonise the electricity system to a considerable extent and also build a EV transport system, you know, electric transport system. Very inspiring.
Very much for a nice presentation. I'd like to ask about the Gulf Stream, like slowing down. What are the current, most reliable predictions? So let's say, like just mitigating the increase of temperature across Europe, or give Europe the stable conditions over the next decades, or it will even override the global trend. What are the current most reliable predictions for this?
Yeah, look, the Gulf Stream brings a very considerable amount of warming to Europe. I forget what the precise figures are in terms of degrees Celsius. But, you know, if you look at where London is, what is London's about 49 north? I think I don't remember the exact northern latitude, but compare it with, say, the equivalent in Canada, which is tundra. You see how much warming is brought to Europe. From what I've read, and I'm no expert on oceanic circulation, but from what I've read, people are observing already the Gulf Stream slowing and faltering. And partly that's because of the melt of the Greenland ice sheet, which when the ice sheet melts, it brings cold, fresh water to lay on top of the ocean, and that stops the downwelling of the super salty water that should be occurring in the North Atlantic. But if I could just say that the one area where I am more familiar, because Australian scientists study it, is what's happening around Antarctica. So the downwelling of cold waters around Antarctica is also faltering. In part, we think because of the melt of the peripheral ice sheets around Antarctica, the floating ice sheets, and that over time will have a very significant impact if it continues, because those downwelling waters bring oxygen to the deep ocean. So if we see a continued diminution of that flow, we will see a deoxygenation of the deep ocean. So, but that's centuries away. But still, you see the ocean circulation. If it does change, it will be quite a serious problem for us.
Somebody was thinking that, yeah.
I would like to ask, considering the global situation with how Europe is failing in competitiveness in terms of economical and also, in a sense, political battlegrounds with the US and China, for example, what would be your recommendations to us as Europeans to try to influence policy towards something that doesn't go in a very contradictory way to this big onset of, green-friendly policies that started recently, but have kind of ended up at an impasse with a lot of the European population, partly due to how more extreme parties are coming.
Do you think Europe really is failing? I don't know. I'm just a...
I would say that we are becoming less and less competitive.
Yeah.
And because of that, there may be a little bit of a problem in prioritizing green policies since people are more bothered by their immediate financial concerns.
Yeah. I think that we have a crisis in the political system, to be honest with you. There's more than enough money to make everyone happy. The trouble is distribution. How do we tax the wealthy is the big question for Europe and the rest of the world, really. And how do we get money out of politics to a greater extent? I think they're the two big questions. But beyond that, if you think about any empire that is kind of slightly past its peak, there is always a pushback. So Britain is a good example, where Britain, was within my living memory, the British Empire was a marvelous thing. We remember the James Bond movies. Britain had a place in the world, an important place in the world. No longer, no longer. And so we have Brexit, and so we have the right-wing parties. Russia, its empire is collapsing. The same sort of problem. People have difficulty coming to terms with the new status quo. And the US is exactly the same. The golden age for the US was the 1950s and 60s, just immediately after the Second World War. So all of them have the same sort of problems. The world is changing. The developing nations are taking their place in the sun, as they should. And we need to come to terms with that, I think, as others, and think about how we treat each other better in our own societies. Because if we do that, I think we can avoid some of this crazy political kind of stuff that's going on. But anyway, that's where going into politics there rather than climate change.
I've got two questions, if I may. One is a simpler, and it's about the methodology of the graphs shown. How did scientists manage to separate the human from the natural cause? Sure.
So what the way the models work is that they divide the world into smaller and smaller graph areas, and they study whatever is happening within that very tiny graph area. Maybe down to 1 kilometre for the good models. So that's clouds, aerosols, greenhouse gas concentrations, and all of them can be accounted for. So when you're building your model, all you do is say, well, what we'll do is take out the volume of CO2 and methane that is being produced by human industry. So in the modelling, you simply take those numbers out and let the numbers for everything else stay in. So that's basically how it's done. Now, I know there are synergies with clouds and everything. There's going to be, there's a lot of detail around the edges, but at a very broad level, with that, it gives you the sense that we cannot arrive at the reality without including the human influence. That's really the key thing, but it's done through a simple accounting method like that.
Thank you. And the second part was my colleague. It's how to not persuade, but explain the situation to an uneducated people that don't understand it and only see the problems with their life status growing down while people are still living. Some people are still living in higher
yes,
like luxury. And how do you explain that it's good for it's better for the future? It just takes time. How do you make it more popular opinion to go green to a broad public?
Could I just take that first question about level of education? So some of the people who are most acutely aware of the impacts of climate change have no formal education at all. And I met people like that in the Pacific Islands and Africa and other places where the people are very dependent on their crops for a living, and they watch the weather very carefully. And they will tell you, absolutely, things have changed incredibly in the last 20 or 30 years. And I'll tell you exactly how they've changed. So I don't think level of education is much to do with it. It's exposure to the consequences, So I think I've spent a lifetime in Australia, talking to people about climate change, whether they're coal miners or others. And I think if you treat people with respect and you give them access to the facts and you engage on an honest dialogue with them, you can make progress in terms of understanding. I really believe that's the case. The other thing about some people not doing so well while others are doing well, that's a social problem. And we can fix that with our politics, That's why we have democracies to fix problems like that.
Yeah, that was the problem in Europe, that people think that the green policies will lower their life standard and will make them poorer, which can affect some people because their salaries are just enough to make them survive, or just to afford some extra things. And now they want to put on the cost of things on the general public as well, the cost of transforming.
So I think that's based on a false premise, I'm sorry, that observation, because our energy systems are coming to a time where they need to be replaced. So the coal-fired power plants of Europe are old. The nuclear plants are often quite old. I don't know about here in Czech Republic, but in France they're old. So we need a new round of investment in energy generation. So the question we ask is, what is the cheapest new investment we can make? And it's wind, solar, and batteries.
Wind energy here in Czech Republic, we don't really have highlands or space for these. The same goes for like water. We don't really have the current for it, or like the ebb and flow electricity or geothermal power. So solar panels could be used on roofs, yes, but still it comes with some technical difficulties. And if you do mass scale, it takes the land from the agriculture.
Yeah, look, there are problems with every energy system in the world.
I'm not against it. I wish we could change it, but it's just too hard to get it to the general public.
Well, it is difficult, but we have to keep trying because the alternative is worse.
Yes.
Every alternative is worse. But, places when you talk about solar, I mean, Germany, the best solar sites in Germany are worse than the worst solar sites in Australia. And somehow Germany's made a massive investment into solar panels, which have had an impact. So I think, we need to have that honest dialogue. We need to people to understand that the time now is to invest in new energy infrastructure. Do you want to invest a lot or not so much? Because if the answer is not so much, then we go for clean energy because it's the cheapest investment.
Thank you very much.
Actually, two questions in a comment. Here you mentioned the solar system, solar panels, and how consuming they are in terms of land or area. But we don't need to put them on a natural area, right? You don't need to put solar panels on a meadow. You can put it on a building or some garages and so on, which are wasted land that can be used for this. And regarding my question, could you maybe tell us about some ways how to sequester, how to mine the carbon from the atmosphere? I've read about some concrete types and so on. And that's perfect.
Yeah, sure. Well, look, just to go back to the solar panels. In Australia, which is admittedly a very sunny country, we have built an industry around putting solar panels everywhere. I would say a third of all houses have solar panels on them now. And I have solar panels on my house, and they reduce your energy costs, sometimes to zero. If you have a home battery, you don't pay for your electricity. And the cost of 7 kilowatts installed in Australia is now about 5,000 Australian dollars, 3,000 euros. Yeah. And the reason is we have an industry built at scale. All of the people who do the installations, they do it en masse and it's cheap. A lot of it is done, the preliminary work's all done through Google, looking at the rooftops and things. And because it's been done at such a scale, it is inexpensive. And it's driving the change in Australia, because in the middle of the day in Australia now, we have what's called emergency low demand. So no one wants the electricity in the middle of the day, right? So that is putting pressure on the few remaining coal-fired power plants because they can't turn off. It's encouraging the development of batteries, regional scale batteries that store the energy from the middle of the day. And so the transition will go on. So it's not, you know, there are examples all around the world you could look at, and you would have to adapt them to the conditions of the Czech Republic. But I do think that, you know, that by looking at those examples and working out how you do it cost effectively, the solutions are there, you know, they're there to be had. But in terms of the ways to get CO2 out of the air, wow, well, there's, let me think. So there was a study done in January this year that asked the question, how much CO2 are we drawing out of the atmosphere and by what means? It turned out that the answer was about 2 gigatons of CO2 through human effort. And most of that 2 gigatons was coming from protecting and regrowing forests. Yeah. And the study made the point that if we were drawing down 3 gigatons, we would be affecting the balance of CO2 in the atmosphere. So we only need to increase our forest protection and replanting by 50%. Yeah. So that's an achievable goal. It will be done almost immediately if people put their mind to it. Yeah. And very cost effectively, yeah, on a global scale. The other technologies we use, like direct air capture of CO2, using silicate rocks, concretes as well, those sort of things. At the moment, they're only having a very small impact, but they can be grown in future. Probably some of the techniques quite cost effectively. So silicate rocks is a good example. If you take olivine, which is a silicate rock, and grind it up very finely and put it on agricultural fields, 1 kilogram of olivine will draw down 1.6 kilograms of CO2 and do it quite quickly. And also trials of crops where this has been done show that you get an enhancement of yield of maybe 10% because you're adding minerals to a depleted soil. Yeah. So the trouble with that solution at the moment is how do we mine and quarry and transport and grind up rocks? We do it using the existing economy, which is dirty. Yeah. So until we clean up the electricity and transport systems, we won't gain the full benefit of using solutions like silicate rocks.
Referring to models predicting increase of temperature, I would like to ask you, what is the current predicted time for ice age coming?
Well, Gavin Smith said it, that the models are no longer of any use to us. And he is the foremost modeler in the world. Really, I'm not kidding. He's like head of Goddard Institute at NASA in the USA, telling you that all of my life I've spent on computer models, and now they are no use to me. I can't use them to predict the things we need to know. So when it comes to the ice age, it's anyone's guess. We need a new approach, and we need to recalibrate the models and understand why the real life situation is at such variance with the models for this last year. There's 0.2 of a degree of warming we can't explain.
It's not been known in the past when this ice age will come, and it's been delaying. It's coming for some time already.
Yeah.
So do you think that the onset of global warming will prevent ice ages coming at all?
Right. I think, yeah, that's a good question. So we need to ask ourselves, why did the ice ages only start manifesting 2.5 million years ago when the Milankovitch cycles that bring the ice age is far older than that? So what was happening before? And the answer seems to be in part that atmospheric CO2 levels were sufficiently high that they overrode the cooling effect of the Milankovitch cycles at their extreme. So the cycles have been there all along, but the atmospheric conditions haven't been conducive to the forming of snowfall, which persists over summer in the Northern Hemisphere. So, you know, I wouldn't like to guess about what the models might say, but I would intuit, just my intuition, that at 470 parts per million CO2, which is like what we had 3 to 5 million years ago, it is unlikely we'd see conditions conducive to an ice age.
At the back.
Thank you. I would like to ask you, since you mentioned the positive role of forestry, it's a sort of climate change mitigator. Some of our research here at the Ecology Center stems from studying response of fauna to agroforestry.
Yes.
And I know that agroforestry, taken as a sort of a global measure, can have some positive messages, especially if it's done with correct crops or the correct trees and crops in combination, obviously. But I know that, for example, for New Guinea and some other islands and areas with very high endemism, any disturbance to the forest fabric may be devastating to many species. I would like to ask what your opinion for nature conservation in these areas would be when we take into account the role of agroforestry.
Yeah. Look, I'm not really familiar with agroforestry, particularly in Europe, and how it's used. And I'm not even sure with those figures that I quoted, do they include agroforestry or do they not? I don't know. But in one instance I am familiar with, which is in New Zealand, agroforestry usually includes a Pinus radiata, a pine tree, which is not native to the area. And it promotes fires, and the crop only lasts 50 years before it's cut down. So there's a very active debate in New Zealand at the moment about whether carbon payments should include agroforestry or exclude agroforestry. And that's become a very political question. I think the science is really on the side of excluding it in the New Zealand case, because in the native forests of New Zealand, they're naturally wet forests. They live, the trees in them live often for many centuries, and they act as very large scale and permanent, for want of a better word, carbon stores. Whereas agroforestry in New Zealand doesn't offer those services.
I think we go first.
As a hydrobiologist, I'm curious about your example of fish shrinking.
Yes.
Due to climate change, because in my opinion, an alternative explanation is overfishing. So could you comment on this?
Sure. Overfishing is part of it, but there is also an overlay of our climate. And the reason that the fish get smaller, at least in part, is that the water warms at depth and there's less oxygen in the water, and that stresses fish, particularly larger fish. So that seems to be part of the explanation for the shrinking size.
It comes from synergy.
Yes, yeah. It's not by any means all, but it's one of the factors.
So, thanks for this question, because I wanted to follow up. I googled the list of the birds which are shrinking. These are terrestrial animals which are shrinking also obviously due to the temperature. So what are here the reasons exactly? And the list of the species which were reportedly shrinking is rather random. There are some northern bird species, but also graphids. So which groups of the birds do you think they will be the most affected?
That's a great question. It's outside my area of expertise, that one. Is there any ornithologists in the room who have an explanation?
Or maybe some groups of the mammals? Or how would it work in mammals?
Look, there is temperature and body size, as we know, are related. So there's a thing called Bergmann's rule, and Bergmann's rule predicts that animals closer to the poles, even though they're the same species, will be larger in body mass with smaller extremities, so shorter ears and so forth. So that seems to be due to thermoregulation, But are species shrinking? I think there is some evidence for mammals. I'd have to look it up though, and I can't answer you immediately on that.
Because in Papua New Guinea, when I had one bird species living at different elevations in different temperatures, I observed the changes in extremities, like the beaks were different in relative to body size, but the whole bird was not getting smaller.
Yeah. Well, that's maybe like Bergmann's rule, that the extremities shrink, but the body mass increases, maybe. At least that's true for mammals. I don't know about birds.
I guess that it can
something to do with the change in population dynamics of the species, maybe higher turnover of the population associated with decrease of body size or something like that. Some complex relationship.
Yeah, it's entirely possible.
Anyway. I wanted to ask about the beautiful animals you showed to us, whose habitat is shrinking due to climate change. And I'm interested in how, if it is known, how unprecedented is this human-induced shrinkage of the habitat, because many of these species are obviously very old, so they probably survived many changes of climate. And I am always thinking that I have no answer to that. How severe is the shrinkage which is coming now?
It's a great question. So both of these animals, I actually described and discovered both of those tree kangaroos. So I know them quite well, and I've been involved with conservation work with them both. So this one here, right? This one is the only tree kangaroo that exists above the tree line in New Guinea. So it's the only tree kangaroo that doesn't live in trees. It lives in the very highest mountains, what's called the mountain, in alpine herb fields and shrub areas. It's got incredibly thick fur, like the fur is that thick, very short little tail. It's a very dopey animal, actually. It's very slow, like a koala sort of thing. But it exists only above, I think the figures are about 2,700 meters. And, you know, there's not a lot of habitat above that. So in times past, during ice ages, this animal would have had a much wider habitat. But, you know, the pre-industrial average of 280 parts per million, that led to the warmest conditions for at least 100,000 years. Yeah. So this species had already shrunk back from ice age times into those few high mountain areas it's found in today. This one here is only found along the northern mountains of New Guinea. We really need a map. I'm sorry, I don't have one, but this particular population in the Jihočeské Mountains, the highest peak is probably, I think it's about 1,800 meters. I don't have the figures in my head, but it's only found from about 800 to 1,000 meters up to 1,800 meters. Again, in ice age times, it would have been much more widespread because conditions were cooler. So it's at its minimum distribution size for 100,000 years before the warming. Yeah. And so this figure here that we have given you is really the result of studies of bird distributions and warming based on historic collections of birds that date back 1 century. And people were able to show that the distribution is shrinking at the rate of about 300 meters elevation per 1 degree C. So if the question is, I think, were they stressed in previous times in smaller populations? I think the answer is no, not as far as we can tell. I mean, back in the Eemian period, stage 5, 100,000 years ago, the Earth was slightly warmer than it was during the industrial period, but not much. You know, so my guess is that these changes are unprecedented.
Mm-hmm.
Yeah.
Then there's no doubt that influence the price of temperatures. But is there any consensus how much can be attributed to natural causes like planetary cycles?
Yes.
Because there is already a fluctuation of temperatures during the world.
Yeah.
And the industrial revolution happened after the ice.
Yeah.
Sunrise can.
Yeah. Look, the global expert on that is a man called Professor Michael Mann, who's at, I think, at Princeton these days in the US. And he says in his talks that humanity is responsible for 110% of the temperature increase. So how does he get to that figure? Well, he says the Earth was already on a cooling trajectory, and that had to be counted by the additional greenhouse gases before we could see an increase. So he thinks that we were heading towards an ice age, probably very slowly, but that cooling trend had to be counted by the increase in greenhouse gases before we'd see a positive temperature change. Yeah.
I can ask, if I remember correctly, then Australia was maybe the first country introducing carbon tax, and then it abolished it again quickly. Could you comment on maybe more general on the carbon tax and on the experience from Australia on this?
Yes. So economically, the most efficient way to reduce emissions is through a carbon tax. We know that. Politically, it's a nightmare. So I was Australian Climate Commissioner during that period, and it was truly terrible. The lies that were being told by the opposition, the fossil fuel industry, were just incredible. But people somehow believed them because they were fearful, you know. The truth is that carbon tax was in place for about 18 months in Australia. It reduced national emissions by 9%, and really nobody noticed the difference on their bills. But the campaign sort of worked. The mining industry spent $100 million discrediting the government through a series of advertising campaigns. And so the government, the progressive government that introduced the carbon tax, was thrown out of office. And very quickly, the carbon tax was abolished. And within about 2 years, that 9% decrease had been obliterated by a rise in emissions. So yes, it's very, very effective, but politically very hard to implement. The big mistake Australia made, I think, was not to give people back the money in their income tax return. If the government wanted this to work, they should have said, here's how much money the carbon tax has raised. We will distribute this back to every Australian through a cheque, through the mail, on a particular date. And if they'd done that, I think it would have stuck. But as it was, people didn't see the benefit, the absolute benefit in that sense.
Yeah. Apart from the impact of climate change on a species level, you know, in general, could you comment on how the impact of climate is having on interactions between different species in a food web or chain?
Yes. How is climate impacting on ecosystem relationships? Yeah. Look, I'm not an expert in that area at all, but I read a little bit of stuff, particularly around the timing of events. So the time that plants produce fruit versus the time that birds may make a nest to breed. And apparently there are some impacts from that disjunction, but I'm not an expert on it. I'd love to know more, but I don't.
I'm sorry, but you didn't cover. I want to ask you about the storage of carbon.
Yeah.
The size of storage of carbon. That the most promising option is to, let's say, plant biomass.
Yes.
Which is short-sighted view because, like, any system in climates will not store carbon, and we will eventually reach it. And here, and I think that everywhere in Europe, biomass is believed to be a clean source of energy.
Yes.
So how does that? So could you tell me? Could you give me a good example of carbon storage?
Yes, sure. So forests are the ones that are doing it at the moment, right? That's the only tool we have that's doing it on a gigaton scale, sadly. So some of the other options we discussed are silicate rocks. Yeah. 1 kilogram of olivine gives you 1.6 kilograms of CO2 stored as carbonate in soils. Yeah. So really geological sequestration.
How much energy do you need for cleaning 1 kilo of olivine?
It depends upon how clean your grid is and your transport system and your quarrying systems. If they were all run off clean energy, it would be fantastic. You'd get the full 1.6 kilograms. But nowhere on Earth I'm aware of is like that. Yeah, we're still dealing with a dirty economy. So we can't use that system. So direct air capture and injection of CO2 into basalts in places like Iceland is very effective. We see the CO2 in the vesicles of the basalt as precipitated as carbonates. The cost of doing it is about $260 per ton. So it's way too high. Yeah. There are other options as well. We can look at growing seaweed, and in areas where the seaweed will drop into the deep ocean and be stored in the ocean sediments, but we don't understand ocean systems well enough to be able to quantify how much is going down and how much is staying there at the moment. There are other possibilities as well, but they give you a 3. I mean, it's concretes. I think Vander mentioned the use of concretes. Some concretes allow for, they're kind of carbon negative. They allow for more CO2 to be trapped into the concrete structure over time. But to be honest with you, we're talking about 18 gigatons for 1 part per million. 18 gigatons. The numbers are enormous. We can't, and we will take decades for any of those sequestration options to scale to that size. Yeah. So increasingly what people are talking about is geoengineering, which offers a short-term fix for lowering temperatures, not lowering CO2 concentrations, but just lowering temperatures, so we avoid some of the consequences of the warming. And of those, probably the best understood is the use of sulfur in jet fuels. Yeah. And the thing about that solution is we actually have the deployment mechanism in place. We have a global jet fleet. Yeah. So we can put sulfur into the fuels, release it when the planes are flying in the stratosphere, and so mask the Earth from warming. The trouble is it's a very poorly understood system. All of the computer modeling on sulfur in the stratosphere has been done using volcanic eruptions and not a more diffuse and targeted deployment like we would with a jet fleet. And also, we know from the volcanic effects that we affect global circulation of the atmosphere. So what would happen if one nation decided to put sulfur in a jet fleet and then the monsoon failed in Africa? What would happen? It's unacceptable political risk. Yeah.
I believe that the sulfur has been recently taken out of jet fuel.
Yeah, it has.
It has been shown that the temperature increased because of this.
Yes, absolutely. Yeah. But to put it back in now, can you imagine? I think it's politically, you couldn't do it without risking war.
Will be also like a risk of acid rain because
yeah, that's another risk.
With carbon.
Exactly. There are no perfect solutions, huh? But you may not use sulfur, you may use something else as well. There are other thoughts. There's cloud brightening processes. People are trying to brighten clouds to reflect more sunlight into space. And some of the early work on that seems to be promising. Where the Australian government has spent nearly $100 million doing that kind of research. So spraying seawater into the atmosphere so that you get very fine nucleation for clouds. There are possibilities, but honestly, I can't see any of them being the white knight that comes to the rescue. Yeah, we have to, hope for the best and work for the best, but prepare for adverse outcomes, which we'll have to live with for foreseeable decades.
What are the most common prejudices that you encounter when speaking about solar, electric cars?
The most common prejudices. I think I believe that we exist within a context, right? And if there is great social inequality and a declining standard of living among the middle class or working class people, that allows populists to gain political power, and they will often do that by blaming what they call elites. So elites might be the purveyors of a new technology or better educated people, you know. And so you end up with prejudices that are mired in this whole unequal system of wealth distribution, which is why I was saying earlier, one of the things we really should do is look at taxes, make sure that the rich are being taxed adequately. Yeah, I don't know what it's like here in the Czech Republic, whether there's a few wealthy people who probably should be paying more tax, and a lot of people in the middle who would benefit a lot from that money. And of course, the wealthy would never feel it. They're billionaires. They would never spend their money anyway. You know, why not deploy that wealth where it's actually needed? So I can see if we can address that problem, I think we do away with some of the prejudices around that, the technologies and deployment of things like electric vehicles or wind and so forth.
I'm wondering what's the nuclear energy program in Australia and what role you see or the Australian government sees for nuclear energy.
The current government sees no role for nuclear, but the opposition party, which is not a hard right populist party, would love to build nuclear power plants. It's hard to understand why, because the nuclear in Australia is very expensive and we don't have any nuclear industry. We don't even have any intellectual capacity around nuclear. We used to have nuclear scientists, but we don't have any. But what I can say in Australia is 10 years ago, we were 90% dependent upon coal for energy generation. We're now less than 50% dependent, maybe 25%. In the next 5 years, that's likely to be zero. So there's so much clean energy is being deployed in Australia that within 5 years, we'll have the job done. So why would you be talking about nuclear power, which would take 15, 20 years to build, you know, when we're halfway there with just the clean energy we have? And I like solar PV because I can have photovoltaics on my rooftop and I run my whole house on it. I run my car on it. I have no fuel costs. I can't put a nuclear power plant on my roof, you know.
When you're speaking about the energy mix in Australia and the percentage of green energy in this mix, I was speaking about only primary or secondary energy.
That's primary. That's, sorry, just within the grid, within our electricity grid, is those figures of 90% and 50%. Yeah. That's electricity generation only. Linda?
Say the current loss of biodynamics plays.
Yeah, it's a hard question to answer because people say they love nature and love biodiversity, but then they seem unwilling to embrace the solutions which will save it, you know. My guess really is not very much. People have other preoccupations, you know. I personally care deeply about it, but I know 100 people who don't. So, yeah.
There are some principles in conservation to be changed regarding this new data. It has been changed since you started studying.
I really do. I think that we have to go back to our conservation efforts with a new understanding that the world is changing quite rapidly. I can think of some examples in Australia where we have species that are restricted to 1 or 2 mountain summits, which are doomed. I mean, they're very close to the edge already. And we could take populations into captivity and release them on other mountains that are less vulnerable. And I do believe that should be done. I think we should think more broadly about nature conservation and not worry so much about what the world has been like over the last 300 years, but maybe the last 3 million years, because the last time we had CO2 levels this high was probably around 3 to 5 million years ago.
If it's okay, I have another question about the energetics again.
Yes.
You used Australia a lot as the example of renewables and how to use it properly. And I'm glad it works out. But how could we possibly do that in Europe, where the population is much higher? So that means higher energy demand and cost, and much less space, which gets me to the thing where you said you have your solar panels on your rooftop, but a lot of people here live in like the blocks of flats or in a rented flat, so they have no probably possibility to change something like this.
Yeah, and again, look, there are all levels of difficulty with this, and I'm not an expert on Europe, you know, but I can look at what's being done in certain countries. Yeah, so Germany is a good example. You would think the last energy source they would ever use is solar, and yet there's solar panels all over Germany. You know, they're widely deployed. In Australia, we are facing that problem of what do we do in urban dense areas where there are apartment blocks, and not only is there nowhere for solar panels, but there is nowhere to charge your electric car. So you don't have a garage necessarily that you can charge. And there are beginning to be some experiments by the government of what are called community solar farms. So this is can be a distributed solar farm where you take available roof space on the local school or on the local factory or wherever you can get it. And the community as a whole owns that. So even though it's not on their roof, they get the electricity as a result of their investment. And then in terms of electric cars, we are deploying charging points, a 7 kilowatt charging point. So these are slow, but overnight they charge your car on electric poles all around the city. And just as we have parking meters, we have electric chargers, you know. So.
Oh, electric poles, like you mean like near streets?
Yeah, right on the street. Yeah, so you just have the charger there for your car. So if you have a car that's parked on the street and you don't have a garage, you can charge it from those points. So we're beginning to think about those problems, but I don't think there is a problem in terms of the energy transition that we can't solve. In Europe, your question might be, is solar really the best? Or should we have a mixture of nuclear, hydro, solar and wind? Or should we be importing from Southern Europe for solar? There's many possibilities.
It is my wish to put some people who understand the matter and come up with a solution into the position where they can decide. Yeah. Because sometimes people who have no idea or just are by lobbies are in the charge and quite sad.
Yeah, and if people are looking backwards to a heavily industrialized past, that stops them looking forward. And that's where you need a leader who come along and say, no, actually, we can do it much better.
You had some comment on that?
Yeah, maybe for your information there, when you speak about Czech Republic and the troubles to implement solar or wind, hence to the geography, maybe some numbers from Germany, then I believe currently the primary energy mix, so the production for electricity only, also already reached a factor of around 60%. So similar situation as in Australia. And when you're speaking about costs per kilowatt hour of electricity in Germany produced by solar energy is around 5 cents, 5 euros, and whereas coal is around 35 cents. So also in Germany, so speaking for Central Europe, with their limited sun, it makes no sense economically to invest in any coal or nuclear, which is even more expensive. So it is definitely possible also in the Czech Republic.
Great.
Thank you.
Okay, we are getting close to our 2 hours, but still we have some time for anybody who wants to ask any questions. Yes.
When you speak about clean energy, do you mean carbon clean, or does it include those things like the lithium batteries and the social inequality and the pollution in countries where this is done? This is also counted? Or is it just a prejudice which
The way I speak about it is just about the carbon emissions for clean energy. But you're quite right that there is no energy system in the world that is perfect. Every energy system has its costs. So, you know, the lithium in the batteries, that is a challenge, yeah? Although, you know, lithium prices are now at an all-time low. They've just plummeted because lithium's quite common in the Earth's crust. So, you know, I have no doubt whatsoever that we can recycle those batteries. They will be recycled. Just on the batteries, it's incredible how long-lived some of those batteries are. You know, Tesla are buying back their old cars, as are, I think it's Mitsubishi, the old, who had hybrid electric cars, because some of the vehicles running after 15 years and 800,000 kilometers on the clock, the battery's still going, and the company doesn't understand why. So we have a long way to go in terms of understanding, you know, the battery technology. But the opportunities there for having very long-lived batteries with very high energy density. I mean, Cattle, you know, Cattle, a big Chinese company, has just announced commercial production this year of 1,000-kilometer range battery for standard cars. So, you know, we're just at the beginning of a revolution, I think, in that area.
That's because we praised China to increasing their carbon emission, but we know that Africa is actually paying the cost of that, right? And unless we manage to think globally,
yes,
at the world scale, we fail.
Yes, absolutely true. I did say that Xi Jinping was the Churchill of the climate movement, and a lot of people hated Churchill, you know. So no one is perfect, but he's taking the country in a particular direction.
But I don't think that's the point. I think if there's a continent who's paying the fact that another place is
yes,
especially for the issue of climate change.
Yeah. Absolutely. But you know, what do we do if we don't? It would be lovely to have a solution to that problem. I wish we had a global system that would allow us to deal with that. But the reality at the moment is either we go towards renewables or we keep up with the fossil fuel system, which is one of the great scourges of the world. You just look at Nigeria and the impact of oil wealth on that country and what's happening. So, yeah, I agree with you, but I wish I had a magic wand, you know, fix it up. Yeah, absolutely.
So related to that, are you optimistic that the democratic system is compatible with action on climate change, or will we end up by, you know, voting for narrow economic interests, which will cause a serious problem with global warming? What would be your feeling about it?
Well, look, I think democracy has such innate strengths that I can see it prevailing over time. You just look at the war in Ukraine is just one example. There you have a country 4 times larger, Russia is 4 times larger, and yet so weak in terms of being able to prosecute a war, simply because people are not buying in. They're not, you know, they don't have as much at stake as the people in Ukraine who are fighting for their freedom, you know. So I think democracy is strong. I do think, though, that we have not got a perfect democracy in the world. And I would love to see a system where we had, yes, voting for some positions, but also sortition, which is this wonderful idea coming out of Europe, where we maybe have a number of positions which are filled by ballot out of the general public. So you're just like we do jury service. Do you do jury service here in?
No, but I think people know how it works. But
so you have to, you're paid to sit on a jury to determine the outcome of a trial. Wouldn't it be great to have some paid positions for people chosen at random off the electoral roll to sit in, say, an upper house, where we have the common sense of the people being brought to bear rather than just the politics of the situation. So I think we've got a long journey to go to see how we safeguard our democracy, improve it, make it better. But I do think it's the system of the future. Dictatorships, if I look at them, the state they're in, not so good, huh?
Okay, let's make this a good conclusion to the discussion. So thank you very much.